Alrighty, so today we're going to talk about factoring by grouping. This method of factoring is actually pretty straightforward. Some of you guys have probably already learned this, so it's going to be a review for you. But factoring by grouping is a way that we can factor a polynomial that has 4 terms. So factor a polynomial with 4 terms. Okay, and so what I want you guys to do is I'm going to give you some steps to factoring. So if you have your worksheet in front of you, maybe off in the corner you can write down these steps, or on another sheet of paper. Okay, so the steps to factoring, the first thing you're going to do is you're going to get the expression in standard form. Now, what do I mean by standard form? That is the powers, or the degrees, are in decreasing order. Okay, so x squared, x, and then your number, or x to the third, x squared, x, and then your number. Okay, the degrees go in decreasing order. That's standard form. Then you're going to group the first 2 terms with the last 2 terms and add them together. And I stress that you're going to add. Okay. Third thing you're going to do is you're going to factor out a greatest common factor from each group. And the fourth thing you're going to do, and I don't know any other way to say this, is you're going to take out the common factor and multiply by the numbers in front. Okay, and whenever we do an example, this is going to make so much more sense. Okay, so first thing you got to do is get into standard form. Then you're going to group the first 2 and last 2 terms, and you are going to add them together. And I'll show you what to do whenever you have a subtraction sign in between there. Then you're going to factor out a greatest common factor from each group, and then you're going to take that common factor and you're going to multiply it by the numbers in front. Okay, so let's look at an example. So this is number 1 on your worksheet. Your homework is the evens. Okay, so we're going to go through the odds, or at least most of them. Your homework is the evens. Okay, so if we look at number 1 here, the first step is to get this polynomial in standard form. So is this guy in standard form? Do the degrees go in decreasing order? Well, yes, it's a cubed, a squared, and then a, and then the constant. Okay, so we got it in standard form. The next step is you're going to group the first 2 and last 2 terms together and add them. So what I'm going to do is I'm just going to take this, these first 2 terms here, and I'm going to put them in parentheses. And the last 2 terms, parentheses. And I am going to add them together. Okay? Now, you're going to factor out a greatest common factor out of the first term. So 12a cubed minus 9a squared. The greatest common factor between 12 and 9 is 3. Well, the greatest common factor between a cubed and a squared is a squared. So what are you left with? Well, 3 goes into 12 4 times. A squared goes into a cubed a times. Minus 3 goes into 9 3. And you don't have any a's left over. Okay? Plus, and then look at 4a minus 3. Can you factor out a greatest common factor? Well, no. So it's going to stay 4a minus 3. Now, right here in front, there is an invisible 1. Okay? So then, we take out the common factor. Now, if you look, that guy and that guy are exactly the same. That is what you need in order to do factoring by grouping. If those two factors are not the same, it doesn't work. Okay? So you can kind of factor out those two terms as one. So you're going to write those as just one term. And then you're going to multiply by the numbers in front. Well, I have 3a squared plus 1. And that is your factored form. Okay? Now always think to yourself, can this get factored? Can this be factored anymore? Okay, well 4a minus 3, that can't. 3a squared plus 1, that can't either. Okay, so you're done after that. So let's look at number 3. Okay, polynomial in standard form. Yes, this one is. So we are going to group the first two terms together and then the last two. And if at any point you need to pause and kind of catch up and make sure everybody's understanding, please do so. Okay, so if you look at the first group here, what is your greatest common factor? Well, 3n cubed minus 4n squared, your greatest common factor is your n squared. And you're left with 3n minus 4. Okay? Plus, well, your greatest common factor between 9n and 12 would be 3. You have 3n minus 4. These are exactly the same. That's what you want. So you're gonna factor them out as one term, so 3n minus 4, and then you multiply by the numbers in front, or the terms in front. So n squared plus 3. Now, can that be factored anymore? Nope, that's as simple as it gets. Okay? So now let's look at an example where you're not adding in between, you're subtracting. So if we look at number 7, okay, whenever you have more than one variable, standard form doesn't really matter, okay, because you don't know which one is your main variable. So yeah, we don't really have to worry about the whole standard form thing. But whenever we group them, before we've always had a plus right in between here. Okay, that's no longer the case. So what I'm going to do is whenever I group, I'm going to grab that negative and I'm just going to stick a plus sign in between here. Okay, so I have 35xy minus 5x plus negative 56y plus 8. Okay, and I'm going to show you why I do this in a second with the whole grabbing that negative whenever you group. So if you look at your first term, okay, greatest common factor between 35xy and 5x, well, that's going to be your 5x. Okay, well, 5 goes into 35 7 times. All you have left is the y. Minus, well, 5x goes into 5x 1 time. Okay, plus, now we look here, what's your greatest common factor? Well, we can take out an 8, and that gives us negative 7y plus 1. So look at your your terms here. Are they the same? Well, no. But they are exactly opposite. So you have a positive 7y and a negative 7y. You have a negative 1 and a positive 1. So how you can actually force these to be the same. How do you change signs whenever you're factoring? Well, you just factor out a negative. So from this second term here, from this guy, instead of taking out the positive 8, I'm going to factor out a negative 8. So I have 5x times 7y minus 1 plus negative 8. So what that does is it changes the signs inside here. Now these are exactly the same. Okay, so my first term is 7y minus 1, and then I have 5x minus 8. Now, can that be factored anymore? Well, no. So you're done. So let's look at another one with a negative in between. So if we look at 9, 9 looks really scary. But if you group it right, it's not too bad. Okay? So again, if you have more than one variable, the standard form doesn't really matter. Okay, so we're going to group the first two and last two. Now I'm going to grab that negative, and I'm just going to put a plus sign in between. So I have mz minus 5mh plus negative 5nz plus 25nh squared. Now here I can really tell you why I'm grabbing that negative out front. If you were to leave the negative in front, so let's say that you would just have negative here. If you know what you're doing, you must factor out a negative there. Okay? So most of the time whenever students are doing factoring by grouping, they often forget to factor out that negative from the second term. Okay? So that's why I say just put a plus in between and you'll factor out the negative later on. Okay? So look at your first term here, mz minus 5mh. What is your greatest common factor? Well, the only thing that's common is the m. So we have z minus 5h. Okay? Oh, squared. I forgot a squared there. Okay? Plus, what can you factor out of this second one? Well, it looks like 5n. So I have negative z plus 5h squared. Okay? So now look at these two terms. They are not the same, but they are exactly opposite. So how do we force them to be the same? This is whenever you factor out that negative. So I have m times z minus 5h squared plus the negative 5n, and that changes to z minus 5h squared. Okay, so then your factored form is z minus 5h squared times m minus 5n. Okay, now one thing I really want to stress is right in between here, there is no addition, no subtraction, it is multiplication. Okay, remember factoring is multiplying. Okay, now if you look at this, can this be factored anymore? Nope, you're done. Okay, congratulations, you just factored a 4-variable polynomial. Pretty good stuff. So let's look at one where we have to get a little creative with our factoring. So if you flip the page, we're going to look at 17. 17 looks even uglier than the last one. Okay? So whenever you group, actually kind of use your common sense here and see if your grouping is going to make sense. So if I group the first two terms, I'm going to grab that negative, put a plus sign in between. What can I factor out of the first group here? Well, it looks like I can only take out an 8x. And I'm left with 2xc plus yd. Okay? Then I have plus. What can I factor out of the second one? Well, it looks like a negative 8x again. And I'm left with 2xd minus yc. Now look at your two terms here. Are those even remotely the same? They are not. Okay, one has an xc, one has an xd. Okay, this is not going to work grouping it this way. Okay, so we're just going to erase all of that. Yes, I'm making you erase. So we're going to rewrite it. So I have 16x squared c plus 8xyd minus 16x squared d minus 8xyc. Okay, here's where you gotta be creative. Grouping the first two and the last two obviously didn't work. Okay, so if you look at this polynomial, what would be good to group with the 16x squared c? And I hope you would say the 16x squared d. Okay, so that means that I'm going to group this 8xyd with this negative 8xyc. So all I'm going to do is I'm going to rewrite this, just switching terms around. Now, whenever you do this, you must take the sign with it. So I'll have 16x squared c minus 16x squared d plus 8xyd minus 8xyc. Okay, now I can group. And look, I have a plus sign in between. It makes it even easier for us. Well, look at your first group here. What's your greatest common factor? Looks like you can take out a 16x squared, and you're left with c minus d. Plus, what can you take out of the second one? Well, it looks like an 8xy, and you're left with d minus c. Now, if you look at these terms here, are they the same? No. Are they exactly opposite? Well, the c is positive in the first one, it's negative in the second one. The d is negative in the first one, and it's positive in the second one. So yes, they are exactly opposite. So how do you get that opposite to match? That's whenever we're going to factor out the negative. And I'm going to take it out of the 8xy. Okay. So I will have a plus negative 8xy negative d plus c. Now, if you're OCD like me, your expression cannot start with a negative. So I'm actually going to switch these around to where I have c minus d. And hey, look, that is exactly the same. Okay, so your factored form is c minus d, 16x squared minus 8xy. Now, can this be factored more? Yes, it can. If we look at this 16x squared minus 8xy, what is the greatest common factor that you can factor out? I hope you're saying 8x. Okay, if you factor out an 8x, and we're just going to put that guy in parentheses, you're left with 2x minus y. And you have the c minus d in front. So factoring doesn't always necessarily have to end up in 2 terms. You can have 3, 4, 5, you can have an infinite number of terms. Factoring means that you go until you cannot factor anymore. Okay, so if I look at this, can I factor that anymore? Well, no, I'm done at that point. Okay? So, use some common sense whenever you're working through these problems. Can this be factored more? Does the grouping make sense? Okay? If we look at number 19 here, so ask yourself, this is whenever you kind of have to think ahead as to what your grouping is going to look like and what your factoring is going to look like. Look at the variables. In this one I have xuv, and here I have xv. Well, what's the only thing I can factor out of those two? Is an x. And I'll have uv in the first one and v in the second one. If I group the next two, I have xu and xv squared. The only thing I can factor out is an x, and I'm only going to have u minus v squared. That's not the same as what I have in the first one, so the normal grouping is not going to work. Okay, so we have to get a little creative. So look at your variables. Which one makes sense to group together? So me personally, I'm going to take the 105 and pair it with the negative 70. And then I'm going to take the the positive 60 and pair it with the negative 90. Okay, so I will have 105 xuv minus 70 xu plus 60 xv minus 90 xv squared. Now let's group. If I look at the first one, yes, these are big numbers, but what is the greatest common factor between 105 and 70? So 5 goes into both of them, but think bigger than that. Okay? If you have a calculator and you do some number crunching, you'll figure out that your greatest common factor is 35. Now what can you take out of your variables? I think you can take out an x and a u. So 35 goes into 105 3 times. You have v left over. 35 goes into 70 twice, and you don't have any variables left over. Okay, so then let's look at the second group. Between 60 and 90, what's the greatest common factor? 30. And then variables, what can you factor out? You can take out an xv. So how many times does 30 go into 60? That's twice. No variables left over there. 30 goes into 90 3 times, and you have 1 v left over. So if you look, these are not the same, but they are exactly opposite. So how do we fix the opposite problem? We factor out the negative. So I'm going to take out a negative 30 xv, and I'm going to switch them right away to where it's 3v minus 2. Okay, so your factored form is 3v minus 2 times 35xu minus 30 xv. Now, can this be factored anymore? The 3v minus 2? Nope, that's done. If you look at 35 and 30, your greatest common factor is 5. If you look at your variables, you can factor out an x. So you're left with 7u minus, 6v? So, can that be factored anymore? Nope, you're done. Okay, so I hope I've shown you enough examples to where you guys can kind of do this worksheet on your own. I will tell you that number 18 and number 20, you will have to switch around. Okay, So like I said, your homework is the even problems only. So for the rest of the class time, you guys can work on this worksheet. Also work on your missing work. Okay, I don't want 100 kids in lunch detention on Wednesday. Okay. Yeah, if you have any questions, let me know on Remind. Okay.